Hello everyone, today we will be recreating the classic Snake game in Python using the Pygame module. So first of all, let's go ahead and import Pygame as pg, sys, time and random. Okay, then let's go ahead and do a pg.init to initialize the Pygame module. And now, as we have done in the last two games, the Snake game is also a two-dimensional game. So we need to create a window using Pygame and define its size on the X and the Y axis. So let's go ahead and do screen size X is equal to 720 pixels, and the screen size for Y is going to be equal to 480. Now let's set the caption of the Pygame window and initialize the game window called screen. So first of all, let's go ahead and do pg.display.set caption, and let's just type here snake. Okay, then let's create our game surface. So screen equals pg.display.set mode, and in here we have to set the screen size X and the screen size Y. Okay, now we have created our screen. Let's now give this a time.sleep5 and a pg.quit afterwards. So what this is going to do is it's going to create a window. It will write up here snake, and it's just going to be blank for now, and after 5 seconds it will automatically shut down. Now for this game I want to set the colors a little bit different. So first of all, let's go ahead and define black equals to pg.color, and now we're just giving the normal RGB values, but we're passing them through the color method of the Pygame, which is basically the same thing as we're doing without using this method, but I just want to set them a little differently for today. pg.color, and in here 255, 255 and 255 for white. Then we have red, which is equal to pg.color 255, 0 and 0. Then we have green, which will be equal to pg.color 0, 255, 0. And then let's set an orange color, and let's set this equal to pg.color, and let's do 255, 165, 0. Let's now set blue, which will be equal to pg.color 0, 0, 255. Okay, and then let's set our clock. So clk equals pg.time.clock. So now we are creating a new clock to use later for the frames per second. Now let's define the parameters of the snake that we're going to draw on the screen. So we need the screen, the snake location and the snake length. So let's go ahead and create a snake location here. This will have two values, one representing the X and the other one the Y value. So first of all, we want our snake to spawn at these two coordinates, and the snake body will be equal to all the places that the snake can have. So this is each set of coordinates represents one cell of the snake. Okay, so for the second one, let's do 100 minus 10, and I'm just doing this this way so you can visualize it a little bit better. And then let's do 100 minus 2 times 10. So it's time, we're just reducing it by 10. So here's minus 10, here's minus 20. I'm just doing it this way so you can kind of understand the reason why I'm picking these coordinates. Now let's do a target location, and let's set this equal to random.randrange 1 and screen size X divided by 2 and rounded up, or actually by 10 and rounded up, and let's do that times 10 here. And let's also do random.randRange 1 and screen size y divided and rounded up to the nearest integer by 10 times 10. And okay, so this here is a variable that gives us the position of the target box on the screen where we will be printing our food for the snake. It will make sense in a little bit as well. So after the target location, let's go ahead and do a print target equals true. So this is a boolean value that represents our print target. It will make sense later. Then let's do a movement equals to right for now, and then a change to variable which will be equal to movement. Okay, and then the score variable which will be set to 0 when we start. So these two here represent the direction that the snake is going to be moving towards. So now let's go ahead and actually draw the initial snake. So let's first of all set the screen dot fill black, and then let's run a for loop for position in snake body. So for every little position inside the snake body, we're going to be creating a new rectangle. So pg.draw.rect, and let's draw on the screen with the color orange, and a pg.rect here, and this will have just the position 0 and the position 1 as a starting x and y, and it will be 10 by 10. So for every position inside of the snake body, we will be drawing a rectangle starting from the x and y of that particular position, and it will be 10 by 10 pixels in total. Okay, pretty self-explanatory. So now let's do a pg.display.update to make sure that this all is drawn on the screen, and now let's test it by doing time.slip5 and pg.quit. Okay, let's run this, and you can see we have drawn 3 little rectangles, one next to each other. So this is all we are doing for now. So now let's make the snake able to move. So far the snake is not able to move, we're not able to control it. So the way we're going to create this movement effect is by removing one place at the end of the body and placing a new one at the beginning. So it looks like it's moving by deleting the end and adding something to the top. So let's go ahead and make that happen. So let's go ahead and delete all of that under the score. So let's go ahead and define a flag and set this to true. And now let's do while flag. So this is our game loop now. Let's set up the event handler first. So for event dot type, or actually for event in pg.event.get, we're going to check if our event type is equal to quit, and in that case we're going to set the flag equal to false so we can exit our game loop. And this is actually meant to be pg.quit. Now let's do else if the event dot type equals pg.keyDown. So in this case, okay, so now let's detect the key press. So if we're pressing down a key, we want to check if the event dot key is equal to pg.k_escape, and if that is the case, we want a pg.event.post, and this I will explain this in a little while. We haven't seen exactly that yet. Event and quit. So this is just like quitting in a special way. So then let's go ahead and we're done now with our event handler. So now let's get outside of the event handler and let's do snake underscore location 0 here plus equals 10. So we're adding 10 to the x position of our snake's location. And then let's do a snake body dot insert 0 and list of snake location. So here we're just inserting a new head for the snake. So then let's go ahead and do a snake body dot pop, and this is just going to remove the last element of the snake's body, so it looks like we're moving by inserting one and removing one. So screen dot fill black here, and now let's do the same thing that we did before for the snake's position. So for pose in snake body, pg.draw.rect, we are drawing on the screen with the color orange, and let's draw a pg.rect starting from position 0, which is the x, position 1, which is the y, and this will be again 10 by 10 in size. So after the for loop, let's do a pg.display.update, and let's do a time.sleep1. So we're moving in 1 second intervals. And now let's outside of our game loop. So if this becomes false by quitting, we are just going to go outside our game loop and do a pg.quit. Okay, now let's go ahead and run this, and you can see that the snake is slowly moving, but the problem is we cannot control it yet. So it's just a moving thing, but it's not really a game yet. So let's see how we can control the direction of the snake. So now to change the direction of the snake, we will have to change the snake location parameters. To make the snake move upward or downward, we will have to update the y parameter, so snake location 1. And to change the direction of the snake right to left, we will have to update the x parameter, or the 0 index. So let's see how we can do that. Okay, so let's go ahead and go inside of our event handler here, and inside of the key down if statement, let's also check for if or else if now the event.key equals to pg.k up. So this will just make us, or we could add the w as well, so event.key equals ord w, and this is sort of like a method that returns the Unicode code for each specific letter that we type. So just keep in mind that this just checks if we press the up arrow key or the W key. So then let's change the change to variable to up. Okay, now let's just copy this so we don't have to type it again and again, and let's add it 3 more times. Now let's do a k underscore down, and let's set this to S, so we're doing the down arrow key or the S. Let's set the change to down. Now let's do k underscore left, and let's set the left equal to A. And now, and actually I think I should do this with lowercase letters here. Okay, so this should be left here, and now key underscore right, and for the letter is going to be D, and this is going to say right. Okay, so now let's get out of our event handler and let's actually change the movement. Now, because if we're moving, for example, to the right, we can't actually switch immediately and move to the left, so we're gonna have to take cases against that. So let's do if the change to variable is equal to up and our movement is down, or actually if our movement is not down, we will allow it to change the direction. So movement equals now the it depends. Here you could either use the change to, or you could use up to make this more clear. So now we're just taking a case against the possibility of wanting to move upwards, but we're already moving downwards, so we're not we can't allow that to happen. So we have to check for this kind of thing if that happens. So if change to now is equal to down and our movement is not equal to up, then we can allow the movement to shift to down. And the same thing now with right and left. So if it is left and the movement is not towards the right, we can allow the movement to change towards the left. And finally, change to right and the movement is not equal to left. Okay, so if this is true, we can change the movement to right. Now let's actually use the movement variable now to determine what the next position of the snake is going to be. So let me make some space here. If the movement now is equal to up, we are going to make the snake location 1. So remember, this 1 represents that we're talking about the y value. 0 means that we are talking about the x value. So let's go ahead and use the y value now because we want to move in the y axis. So let's do snake location 1 plus equals or actually minus equals, because we want to move towards the top, and let's do 10 here. So else if the movement is down, we want to do a snake location 1 plus equals 10. So else if now the movement is equal to right, we want to do a snake location 1 plus equals 10. And now else if the movement equals left, we want to do a snake location of this should actually be 0 now because we're talking about the x-axis, and this should be minus equals 10. Okay, now let's actually update the snake's body after that, and let's delete all of this stuff here so we don't get confused with the previous code. Now what we want to do is do a snake body, not location, body dot insert, and we're inserting 0 and list snake location. So we're just adding a new node here, and we're also snake body dot pop, so we're removing the last one as well. Remember, this just makes it look like it's moving by removing the last one and replacing removing the last one and adding a new head. So then what we want to do is screen dot fill black to fill it with black color, and then we just leave this as is. The display, the we can actually do here a clock dot tick 5. So this is just a 5 frames per second. So now let's see if it actually works. So I'm just pressing the different arrow keys now, and as you can see, it is able to move just like the regular snake. And the 5 frames per second give this kind of a chunky look that we're used to play snake at. So now let's go ahead and create the mechanism that gives the snake the food in order to grow. So this is done by this target location here, which by target it means the food, and as you can see, it will be randomly generated at an X and Y on the screen, and this here decides when we want to print it. So if it becomes true, that means that it's time to print the food on the screen. So let's go ahead and add this just once at the beginning. So first of all, let's do a pg.draw.rect, and in here we want to draw on our screen with the color white because this is the color of the food that we're going to be using. pg.rect, and now the target location 0, the target, remember the target is the food, target location 1, and we want this to be something like 10 and 10, so 10 by 10 pixels here, or you could just make it smaller, like something like 8, a little bit smaller than the snake itself. And then now as you can see, it's randomly placed on the screen. Now if I close this and rerun it, it will be at a different location. So but as you can see, if I go ahead and move over the food, I will not actually be able to eat it. So if you see, I'm not actually able to do anything here. And I think it would be best if you leave it just at 1010 in order to be more centered. But now let's go ahead and make the snake eat the food. Now what we need to change is in here, after inserting the new node, instead of just popping the previous one anyways, we could do if snake location 0 equals the target location 0 and the snake location 1 is equal to the target location 1. So essentially, if they are on the same coordinates, that means that they are on top of each other, that they are touching each other. So that means that the print target will become false. And now else we could do a snake body dot pop. So this is the if statement that we're going to be added, and then we're going to say if not print target. So if this is false, so if they are actually touching, we could say that the target location is now changed to something else. So random dot rand range, and this is just like we did before. This will be at the screen size x divided by 10 and rounded up to the nearest integer times 10. And for the y, it will be random dot rand range 1 and screen size y divided by 10 times 10. Okay, and actually this needs to be outside of here, and this as well. Okay, that's pretty much it. Now if this happens, we need to just pick another target location and also set the print target equal to true. So now let's create, or actually I think that we are done for this part. So if we go ahead and run this, let me try to catch some food now. Okay, so as you can see, I was able to eat the food, and as you can see, the snake also grows as I'm consuming more and more food. And I'm just going to pick up a few more of these white blocks to see that it's really growing in size. And if you want this game to run faster, you could just increase the tick rate. So okay, enough of this. So if you wanted to run faster, you could just increase this. I'm just going to do 10 here to see the big difference. This is a bit too fast, but I'm just showing you an example if you want to make this slower or faster by adjusting the frames per second here. So now let's actually manage the score. So let's go ahead and define a method for that. So let's define the show score, and this is just going to be printing some text. So let's go for choice here, color, font and size. Now the score font is going to be equal to pg.font.sysfont, and in here we're just going to put font and size. This is pretty standard, we've done this many times before. So the score surface here is going to be score font.render, and we're just going to say score, and then we're going to do the string value of our score variable and set this equal to true, and also the color. So this is pretty standard text rendering. So now let's also define the score rect here. So scr surface dot get rect. Okay, now if our choice is 1, we want the score rect dot mid top to be actually the screen size x divided by 10, and also 15 as the size, or no, not the size, the actual y value. So else the score rect dot mid top, we want this to be equal to the screen size x divided by 2, and the screen size y divided by 1.25. Now let's split this on the screen. So screen dot split our score surface, and let's give the score rect here. So now let's actually call this method over here. So we're going to call the show score, and we're just going to give the parameters 1 white, and let's use the Consolas font, and size 20. So if we run this, you can see that our score is displayed here. So it's not actually functional yet. Okay, so it's not actually functional yet. You can't see the score updating here, but the reason we included this choice here is because if we set this to any different number other than 1, our score is going to be displayed here other than the position on the top left. So it's like you have a choice of where you want to place the score. You have 2 choices on that. So finally what we need to do is define the ended method, and what this will do is it will be called if we actually lose. So if we actually hit the walls or our own body, we will have to end the game. So let's add a my font equals to pg.font.sysfont, and let's do times 40. So this is our font object. Now we need to do ended surface here, and just let's render our font just like we've done many times before. Render and let's say game over. Let's set this equal to true, and also blue color. Now the ended rect will be equal to ended surface dot get rect. Now let's also set the coordinates to ended rect dot mid top. This will be equal to our screen size x divided by 2 and screen size y divided by 4, let's say. Okay, so now let's fill the screen with black, screen dot fill black, and then paste it on the screen. So screen dot split our ended surface and our ended rect here as the parameter. Now let's also call the show score with the 0 blue and times here, and also 20. So we're just showing the score. Let's do a pg.display.flip, and I will let you know what this does later, for example, just by using an example. Then let's do a time.sleep 5 and a pg.quit and also a system exit. Okay, now what we have to do is we need to actually increase the score here. So here we should do scr plus 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 now, or just plus equals 1. And then what you could do is you can check how to end the game. So in here, after just drawing the snake, you could just go ahead and do an if statement. So if snake location 0, so if the x value of the snake is less than 0, or the snake location 0 is greater than our screen size x minus 10, that means that we have to call the ended method. Now else, or elif, our snake location 1, and you could just put these inside a you could just do or this or that, but in order to make this look more clean, I'm just using the else if statement now. So if the snake location 1 is 0, so if it's gone far from the top, or the snake location 1 is greater than the screen size y minus 10. So if this is true, we need to call the ended method again here. And now let's see what happens if the snake touches its own body. So for block in the snake body, and we're going to be using we're going to be starting from the first, or actually the second element of the list, and we're just going to see if the snake location 0 is equal to block 0 and snake location 1 is equal to block 1. So we're sort of taking each and every block of the snake and we're comparing it to its other one, and if we find two blocks that have the same coordinates, that means that the snake is touching. So what we want to do in this case is just call the ended method here, and I think we should be done. Let's go ahead and run this, and let's go ahead and see what happens if we eat the food, if the score updates. Okay, so we can see that the score has been updated. You can see now it's 2. If I eat another piece, it's going to become 3, and then 4, and I think I'm almost big enough to touch the body of the snake. Okay, so I touched the body of the snake, and you can see that we have displayed the game over here. And if I go to the top, you can see the same thing happens, and actually we're switching the score over here so we can see it more clearly. And I think that's it. Our game is now done. So as exercises, what you could do is you could add some borders to the game or to the snake so it doesn't look so plain. You could add a random color to each segment of the snake if you wanted to make it look fancier. And you could replace the box food with an image of a fruit, for example. This is what you could do to make this game more good looking. So this is just the basic mechanism of how a snake game would work, or how it would be implemented in Pygame. So feel free to be creative to add any sort of features that you might like. So for example, what I could do right now is go ahead and define a variable called level, and I could set this equal to 10, for example, and I could change the tick rate to level. So I could have a mechanism that increases the level, so it increases the speed of the snake, and its new level, it becomes faster. So you could say if I reach a score of 10, I could then go to the next level, and so on. So you could have a snake game that has levels, and it's not just a plain snake going around and eating the food. Okay, I think that's it for our game today. If you have any questions, as always, just review the code again, and I'm sure you'll understand by now. We've done more complicated stuff in the past. Okay, I think that's it. I'll see you on the next lesson. Goodbye.